My name is Dietrich, and I will be presenting on applying linear and integer programming to the online world of EVE Online. To start off, we have to understand what is EVE Online. It is a space-based multiplayer game set far into the future, with a few unique aspects, with one being it is a single shard world, meaning that all actions that take place in the game happen within one shared universe. It has a player-driven economy, which means the economy is run by the players with player-made items from player-gathered resources, and it is a sandbox. There is no one set way to play the game. It is up to the player's initiative to determine how to play the game most efficiently for their playstyle. In EVE, there is various manufacturing methods. However, I'm only focusing on Tech 1 production, which uses exclusively minerals as the materials to build items in the manufacturing process. There are two ways to get minerals. You can either buy them directly off the market from another player, or mine or buy ore off the market and refine the ore into minerals. The logistics of moving minerals is much greater than moving ore in its compressed form. For example, to build the largest ship in the game, the amount of minerals to build it takes up approximately 48.7 million cubic meters, while the same amount of ore in its compressed form takes up about 2.7. So the problem, what types of quantities of ore should I buy or mine to get a desired amount of minerals with the smallest amount of volume of ore? In other words, what optimal amount of ore should I buy to get a certain amount of minerals so that I have to spend the least amount of time moving it or the least amount of money paying somebody to move it for me? It sounds like an easy problem, but whenever you consider there are 16 ores with 3 variants each giving a varying amount of minerals with a differing amount of volume each, it can be quite the complex problem. However, there is a solution, linear and integer programming. Linear programming, I used the simplex method, which, however, the simplex method cannot solve for integer solutions on its own, meaning since I can't have half a unit of ore or 2/10 a unit of ore, I need another method to solve for the integer portions, and that being the branch and bound method. The other challenge of my thesis involved me writing a program to implement this type of tool into my current website, which uses Ruby on Rails and Angular 6. And I have a short demo using the finished product. For example, if we wanted these 3 types of minerals and that amount of quantities, you could just type in, say, you wanted 2 million of this, 500,000 of this mineral, and 10,000 of this. You wait a few seconds, scroll up, and it breaks it down to what ores you should buy in what quantity, and breaks it down to how much volume each set of ore takes up, as well as the total volume. And then on the left, there are also filters on what ores should be used if you want to say only use the more common ones or only use the base variants of them to save money. Now that I had a working model, I needed a method to test it to make sure the answers were returning accurate, feasible, and answers in a timely manner. So I chose 40 random items from the game to use as test cases. I ran them all on my home computer so that each test run had its own baseline and were comparable, not running them on less superior hardware would skew the results. I also ran each item with varying differences of tolerances, meaning if a value was within plus minus a certain number of an integer, it would be considered an integer. For example, if the tolerance was 0.1 and the value that it solved for was 8.9, it would consider that an integer even though it's not. And then I compared each test run, accuracy, speed, and the amount of branch and bound nodes it took to solve. Version 1 was pretty decent, achieving a accuracy of about 94% compared to OpenSolver, which is a plugin for Excel that solves these integer and linear programming problems. with the accuracy decreasing as well as the time as you get to a less strict tolerance. Iteration 2 involved me updating the program of how it handles the tolerances, splitting it into 2 different tolerances, one being the case I mentioned earlier, and another being if a value is very, very close to an integer, how it would get rounded up or down. For example, 8.9 repeating, that would be considered 10. The results were a little bit better accuracy-wise, but overall the time actually went up, which is the opposite of what I wanted. Moving on to iteration 3, this involved implementing breadth-first searching, meaning it would solve the branch and bound tree from top to bottom, similar to like a family tree or a hierarchy chart, from the CEO down to the employee. This brought about a very good increase to both speed and accuracy, nearing 100% accuracy as compared to the professional open solver solutions, and bringing the time down over 50%. The values in parentheses are the one from the previous iteration for easy comparison. About a month ago, I discovered a new programming language called Crystal. It is a statically typed, compiled, relatively new language as compared to Ruby, which is dynamically typed and interpreted. And since it has Ruby-like syntax, I was able to rewrite my program in a couple days to Crystal, and then I ran the test again to see how it compared. Overall, Crystal solved the same 40 items in an average time of about 9 times faster than Ruby, with a little bit less accuracy, but that's mostly due to me not having enough time to optimize the new language's algorithm. And it also should be noted that Ruby was capped at 1,000 branch and bound nodes, whereas Crystal was 35,000. So in the same amount of time that it took Ruby to solve 1,000 nodes, Crystal was solving 35,000. So overall, future improvements would obviously be converting everything and optimizing the Crystal program to take advantage of that raw speed that it provides. Getting better hardware. As of now, my website is hosted on a Raspberry Pi type maker board, which does not have as much processing power as my home computer, as well as adding additional features such as optimizing for the least amount of cost, or including skills, bonuses, implants that affect how much minerals you get from refining ore. The conclusions that I came up with after developing this, I chose to go with a 0.5 tolerance, as that provided very accurate results in the least amount of time. And since this is a real-time program, you do not want to have the user wait around for a minute or 30 seconds at most to get their results. Breadth-first search was offered a very good improvement to the speed and quality of the results. In Crystal, once it would be optimized to do this type of algorithm, it would be much, much better for the user, providing probably near 100% accuracy with under a second results. Any questions? Yes?
How did you run across Crystal? How did that?
Well, if you have an Android phone,
No.
on Android, they have like, if you swipe to the right, they have like news articles that you might be interested in. And it's like, Crystal, slick as Ruby, fast as C. I'm like, oh, I'll check that out. And as it turned out, it's pretty great. Yeah.
What made you choose this as your thesis?
Well, I didn't want to write a big paper, so I wanted to do a creative project that actually deals with my major and something I enjoy doing. And it's turned out to be a pretty perfect project. Yes?
Is there a reason you chose the game Eve compared to a similar online game?
Eve is very good in its third-party developer support, providing APIs to get various in-game information, as well as every time they release an update, they release the static data files in YAML format, meaning a list of every item in the game's name, ID, volume. So basically, in the program, whenever it runs and you select the ores that it should be using, it's actually querying the database from the static files, so that if the game were to ever update or change the amount of minerals in each ore, it would automatically account for that, assuming I update the data files. So it's kind of future-proof, basically.
Any other questions? Thank you.